Imagine a disease that's so stealthy, so aggressive, that if you don't catch it in time, it can be fatal. Now, what if I told you the key to detecting it, to stopping it right in its tracks, could be as simple as breathing into a bag? Okay, let's dive into this scientific detective story. It's all about a deadly fungus and the hunt for a brilliant new way to find it. So let's talk about the stakes here, because they are incredibly high. The disease is called invasive pulmonary aspergillosis, or IPA for short. And for certain high-risk patients, we're talking people with weakened immune systems, like those getting stem cell transplants, if this thing goes untreated, the mortality rate can be as high as 100%. It's a true silent killer. And that right there is the central mystery for doctors and scientists. You know, when the stakes are literally life and death, and the culprit is this hard to find, how on earth do you create a test that's fast, safe, and reliable enough to actually save lives? That's the case we're going to unpack in this explainer.
All right, so our investigation starts with a prime suspect, a fungus called Aspergillus fumigatus. Now, believe it or not, we all breathe in its spores every single day, but for someone with a compromised immune system, it can turn into a deadly invader. The problem is, the forensic tools we have right now to detect it, they're just not cutting it. And you can really see the problem when you look at the options on the table. A biopsy, sure, it's the gold standard, but it is incredibly invasive. It's slow, and it's super risky for patients who are already very, very sick. Okay, what about a CT scan? Well, it's not specific, and a lot of the time it just misses it. And the blood tests that look for fungal DNA or antigens, they're just not reliable, and they can't always tell you if you're looking at a harmless fungus just hanging out or a full-blown deadly invasion. We desperately needed a better clue.
And that brings us to the big breakthrough. Scientists found a clue. They discovered that this fungus might be giving off a unique chemical scent, a kind of volatile fingerprint that could totally betray its presence. And that chemical is called 2-pentylfuran, or 2-PF. It's what's known as a volatile organic compound, a VOC. The easiest way to think about it is like a microscopic scent molecule. As the Aspergillus fungus grows deep inside the lungs, it releases this 2-PF, which then gets exhaled in the patient's breath. So here's the bottom line. If you can detect the scent, you can find the fungus.
I mean, the potential here is just massive. All of a sudden, you're not talking about risky biopsies or unreliable blood tests anymore. You're talking about a simple, totally safe breath test. A patient just breathes into a bag, and a machine analyzes it for that chemical fingerprint. This could find the disease days, maybe even weeks earlier than the old methods. That would be an absolute game changer for treatment and for survival.
But you know, in any good investigation, you can't just take one clue and run with it. You've got to interrogate it, you got to test it, and you have to be absolutely sure it holds up. Scientists needed to know for sure that this chemical scent was truly coming from the dangerous, invasive form of the fungus.
And this is the question that really drives the next part of the research. How do you prove that link? Well, you take it to the lab. You have to grow the fungus under perfectly controlled conditions and see if the evidence actually holds up.
And here is what they found out. It turns out the fungus has two main ways of growing. There's the spore-producing form, which happens where there's lots of air, but then there's the vegetative form, the one that actually invades deep into lung tissue. And this was the key finding. In the lab, they saw that this dangerous, invasive growth produces way, way higher levels of 2-PF. This was the smoking gun. A strong 2-PF signal in the breath points directly to an active, dangerous infection.
So just when it feels like the case is coming together, a major plot twist, a huge complication that could throw the whole investigation completely off course. What if that chemical fingerprint isn't so unique after all? Right. This is the problem of imposters, or what scientists call confounders. See, if other things can produce the exact same chemical, you risk getting false positives all over the place. A breath test that's just constantly setting off alarms for healthy people is, well, it's useless. So the hunt was on to find any potential imposters that could be mimicking the fungus's scent. And the hunt for these imposters led them to a really surprising place, the dinner plate. Turns out that chemical fingerprint, 2-PF, is found in a whole bunch of common foods. We're talking about soy milk, nutritional supplements that are often given to sick patients, tinned veggies like asparagus and beans, even things like peanuts and rolled oats. A patient's diet could totally set off a false alarm.
And to see just how big of a problem this was, the researchers ran a really simple experiment. They had healthy volunteers just rinse their mouths with some soy milk, and the result? an immediate, massive spike in the 2PF levels in their breath. This proved that diet isn't just some minor issue. It is a major, major confounder that has to be controlled for if this test is ever going to work in the real world. So, where does all this leave our investigation? Well, the case is far from closed. We've got this really promising clue, but we also have these massive complications. The final verdict on this breath test is really a mix of stunning success and some really frustrating setbacks. Let's start with the success story because it's a good one. In one clinical case study, a patient with a confirmed pace of IPA, the breath test, it performed perfectly. It was this powerful proof of concept showing that, hey, despite all the challenges, this idea has real potential in the real world. And the results were pretty remarkable. Early on, when the infection was active, their breath test kept coming back positive for 2PF. But then, as the powerful antifungal drugs started to work and CT scans showed that the damage in the lungs was improving, the 2PF signal vanished. The breath test accurately tracked both the disease and the recovery. It was amazing. Okay, but a single, really compelling case is one thing. It's fantastic, but it is not enough to get a new medical test approved for everyone. Science demands rigorous proof. So to really validate this test, researchers needed an animal model where they could control every single variable, give the animal the infection, track the breath, and then confirm everything with pathology. And this is where the investigation just hit a brick wall. They chose sheep for their model, but the drug they needed to use to weaken the sheep's immune system, well, it turned out to be toxic to the sheep's lungs itself. It caused so much damage that it became impossible to then give them the fungal infection to study. The perfect controlled experiment was completely derailed by a biological roadblock they never saw coming. So this is where the case file stands today. The evidence is promising for sure, but the complications are very real. We know for a fact that diet can cause false positives. The critical animal model they needed for validation, that failed. And there's this one big lingering question. Could severe lung inflammation from other things, like a bad case of pneumonia, also produce 2PF? Could that create yet another source of false alarms? Right now, the jury is still out. The trail of 2-pentylfurion led us to a place of both incredible promise and deep, deep complexity. The scent of this deadly fungus is real, it's detectable, but turning that clue into an ironclad, reliable diagnostic tool, that's a case that remains unsolved. And it leaves us with a really fascinating question. As our technology gets better and better at listening to these subtle chemical whispers from our bodies, how will we learn to trust what our own breath is trying to tell us?